Yes, I welcome you, dear students, to next lecture on differential equations. Last time we did the classification of differential equations. We classify the differential equations in two groups. One is ordinary differential equation, and second was this partial differential equations. Actually, we are here at this time in the field of ordinary differential equations. Whatever we discuss, we deliver here, it will be related to ordinary differential equations. Now it is the differential equations I have mentioned here. Ordinary differential equations we are dealing with, lecture number 3rd. We will classify one more classification of this. It is linear and non-linear differential equations. It is linear and non-linear differential equations. Let us have definitions on this. A differential equation, well, we have here the definition of this linear and non-linear differential equation. We wrote here, a differential equation is said to be a linear if, number one, every dependent variable and every derivative involved occurs in the first degree. It should occur in the first degree. Dependent variable, why? Dependent variable should be in the first degree, and its derivative should also be in the first degree, remember. And no product of the dependent variable and derivative occurs. That is, there should not be y dy by dx term. If it is so, if it satisfies these two conditions, then we say it is a linear differential equation. Is said to be what? Linear differential equation. In case a differential equation which is not linear, that is, which does not satisfy above two conditions, that is, every dependent variable and every derivative involved is not in the first degree, or if there exists the product of the dependent variable with its derivative, that in that case also it is not linear. So we say a differential equation which is not linear will be called what? Non-linear differential equation. This is the definition of linear and non-linear, because in the first phase of this ordinary differential equations, we will be dealing with the linear and non-linear differential equations. We have the fundamental methods for solving linear differential equations, and if a differential equation is not linear, we convert that into linear. That is, differential equation is reducible to linear form. That will come later on. Here at this stage we are defining what is linear and non-linear. I have quoted here 3 examples I have taken. Let us test their character. We will test the character of these differential equations. One is y is equal to x dy by dx plus a times this. We have previously in previous lectures we have also dealt with this differential equation. Y is equal to root x plus dy by dx plus k times dy by dx, and another is third. Now we have to classify among these which is linear and which is non-linear. Let us say let me take this one first. I have y is equal to x times dy by dx plus a times 1 plus dy by dx square raised to 1 by 2. We can write it y minus x dy by dx, then squaring it is a square into 1 plus dy by dx square. You see here order of course of this differential equation is 1, because it is highest derivative that it involves is dy by dx. Order is 1, but it is of degree second. Degree is second. You know how we find out the degree? First we see the order, then we see the what is the highest exponent or power of this order. Highest order, it is 2, so it is degree is 2, therefore it is not linear. This differential equation is not linear. Differential equation is not linear. Okay, it is not linear. So we have tested this character by verifying it is this degree is second, so it is not linear. Let us take this one, the second example, which is your simple example. Y is equal to root x dy by dx plus k upon dy by dx. We can of course write it y into dy by dx plus root x into dy by dx square plus k. Now if you look at this differential equation, it is of order it is of order 1, highest derivative in order, but degree is 2 here. The highest derivative is dy by dx. What is it? Is highest power, highest exponent, it is 2, so it is degree is second, so it is not non-linear. It is a non-linear. We can also say here that there exists a product of dependent variable and the derivative. In that case also it ceases to be linear. Well, you have this example, third example. It is dy is equal to y plus sine x dx. It is simply dy by dx is equal to, you can write it, y plus sine x, so it is of degree 1. It is of degree 1. It is a linear. It is degree 1, degree first, so it is what? It is linear. It is linear differential equation. So this is what we mean by linear and non-linear ordinary differential equations. Now let us gradually come to the solution. What is the solution of the differential equation? How many types of solution we have? Methods of solution. We will discuss them, and then you can go directly to the problems very easily. Now we have the solution of a differential equation. How we find out the solution of a differential? What is actually the solution? Suppose you have a differential equation. It involves dy by dx plus x terms, y terms, dependent variable y, independent variable x. What is solution? Solution is actually a sort of relation between the dependent variable and independent variable, such that this relation and derivatives obtained from this relation, when substituted in the given equation, makes the given equation as an identity. That is, it satisfies the given equation. Then this is called as the solution, general solution, or we also say sometimes this solution as a integral. Solution of a differential equation is also sometimes called integral. Remember this. So let us define the solution. By the solution of a differential equation, we mean a functional relation between dependent and independent independent variables involved. Relation between dependent and independent variables which are involved in the equation. The functional relation between dependent and independent variables involved, so that this relation and derivatives obtained from it, from what? From the functional relation between y and x, so that this relation and derivatives obtained from it when substituted in given differential equation reduces it to an identity, that is, satisfy given differential equation. In other words, it means the relation between y and x, where y and x are the dependent and independent variables, suppose involved in the differential equation. If we are in a position that we get a relation between y and x, or whatever the variables are involved, and the derivatives we obtain from this relation, then substitute this relation and the derivatives in the given equation, makes it an identity, reduce it to an identity, that is left side is equal to right side, then we say the given differential is the solution of the given differential equation, is the solution of the differential equation. And you will note here very important thing, it is a very important observation. Important observation is, it is, I will write here, then you should note it, then this relation is called solution when it satisfies the given differential equation, solution or integral, note it, or integral of given differential equation. That means in certain cases we call the solution as integral, that is why I have mentioned here is called the solution or integral of the given differential equation. When you have a certain relation, you obtain the derivatives from that relation, use this in the given differential equation. If it satisfies it, then we say it is the solution. Sometimes we say it is an integral. But I was telling you, you have an important observation here. It is important. Important observation is this: the solution of differential equation, the solution of any differential equation, whenever you find out the solution of a differential equation, you solve the differential equation and you have come to know what we mean by the solution. It is the relation between x and y. If the differential equation involves dy by dx plus x terms and y terms, it is the relation between x and y, and this relation should satisfy the given differential equation. And when you find out the solution of any differential equation, it should not involve derivatives. Remember this. That is, we write the solution free from derivatives. Solution differential equation will have the derivatives of its own, but when we find out the solution must not involve derivatives, and you will take care of this. Now I will discuss here the types of solutions. How many types of solutions we have? We have the general solution of a differential equation, we have the particular solution of a differential equation, we have also a singular solution of a differential equation. Let us write it. Let us see, we have types of solutions. First type I will take general solution. What we mean by the general solution? General solution is sometimes also called complete solution, complete integral, and complete primitive. It is also sometimes known as complete primitive of the differential equation, or complete integral of the differential equation, or complete solution, general solution. Now, what is the general solution? Let me discuss this. A solution of a differential equation which involves number of arbitrarily constants equal to order of the given differential equation. What I wrote, a solution of a differential equation which involves number of arbitrarily constants which are equal to the order of the given differential equation. Remember this. If we have to solve a second order differential equation, second order means where you have the highest order derivative d2y by dx square, second order, then the solution must involve two constants. If you have the differential equation of fifth order, its solution must involve 5 arbitrarily constants, different, that is, they should be independent, not dependent constants. If they are independent constants, we can reduce if they are dependent constants, we can reduce sometimes 3 into 2, 5 into 4. So we say these are independent constants. Okay. So if a differential equation is of order n, nth order differential equation, how many constants that should involve? Okay, that should involve n arbitrarily constants. So if you have a differential equation of order first, that should involve only one arbitrarily constant. Differential equation of order 2, 2 arbitrary constants. Differential equation of order 3, 3 arbitrary constants. Similarly and so on. Differential equation of order n should involve n arbitrarily constants. Then the solution will be called the general solution. Remember this. Then this solution is called general solution. Sometimes we say the same solution, general solution, or we may say complete solution. We sometimes also call it complete primitive, complete integral, or complete primitive. Complete primitive. Remember this. General solution or complete solution, it is one and the same. Complete integral, one and the same. Complete primitive, one and the same. But it has a peculiar property that it should involve the number of constants equal to the number of order, equal to the order of the differential equation. Is it clear? Now let us go second type. It will be this particular solution. What is a particular solution? particular solution. Particular solution. What we mean by particular solution? By particular solution is if we give particular values or fixed values to the arbitrarily constants. In the previous solution, you will have the constants there equal to the order of the differential equation. But in this solution, you don't have the constants. Actually, constants are replaced by some particular value or fixed value. Now the question given in the general differential. First we find out general differential equation. And it involves constants. And if in some cases, under some conditions, when there is given, these are known as this boundary value conditions. You will come to know about boundary value conditions later on when we go ahead, because we are in the beginning stage. I cannot discuss here boundary value conditions. So when you have the boundary value conditions there, in boundary value conditions, we get the constant C1 equal to something, C2 is equal to something, C3. The solution, when we substitute those constants by those fixed values, fixed constants, then the solution becomes a particular solution. Okay, let me define it. A solution is said to be particular if arbitrarily constants in the general solution. सबसे पहले first we find out the general solution. If arbitrarily constants in the general solution are given fixed or particular values under some given conditions, depending upon the nature of the problem. You may ask me here, when the differential equation, we find out the general solution of the differential equation. We find out the general solution of the differential equation. That will certainly involve the arbitrarily constants, C1, C2 fixed arbitrarily constants. But how we can replace those by some particular or fixed values? It is under some given conditions. Suppose in the state of a differential equation, when we have the motion of a body, simple harmonic motion, and you are given that the body at the initial point, what is the velocity? When it moves some distance, what is the final velocity? And when it stops somewhere, what is the value of velocity at you use these things. That is initial boundary conditions. When you use the boundary conditions, you get the constants which were involved in the general solution. When you get those constants by given particular conditions of the given problem, we get the solution that will not involve now arbitrarily constants. Now arbitrarily constants get this replaced by some values. That solution will be called what? This particular solution. Then you have the singular solution. What is singular? You must know this, then we can go to solution. Otherwise, finding the solution is blindly, closing eyes and you can find out the solution. But you must know what is the solution, what type of solution we are finding out. And these things are very important when you are facing the MCQ problems. Okay. Well, we have now singular solution, third. Singular solution. What we mean by singular solution? By singular solution of a differential equation, we mean the solution which does not involve arbitrary constants and is not obtainable. It is very important. And is not obtainable from its general solution. It is general solution by giving different values to arbitrarily constants. Well, what is the singular solution? By singular solution of a differential equation, we mean what? We mean the solution which does not involve arbitrarily constants. It is free from arbitrarily constants, remember. But you can pose a question here. You can ask me, the particular solution now becomes also free of arbitrarily constants, because arbitrarily constants there get replaced. There the difference of the particular solution and singular solution is, in particular solution the arbitrarily constants get replaced by some conditions, by some boundary value conditions of the problem. They get replaced there. But here you don't have the arbitrarily constants. Arbitrarily constants do not exist. Even this type of solution, this type of singular solution is not obtainable from general solution. If you try to obtain that from general solution by giving different values to the constants, if it is then this singular solution will become what? Particular solution. But this is not the case. We have mentioned here, and is not obtainable from it is general solution by giving different values to arbitrarily constants. No, you will later on come to know what is the difference between this general solution and this singular solution, how we get. You will get a best answer of this when we tackle this collatz form. When we find out the collatz form, we get two factors. In one factor, we get the value of p involving derivative constant, involving c constant, and we put p in the given equation that involves c. Then there is a second factor. You will see there. I will explain it there. You have a second factor there, and that also satisfies the given differential equation, but it has no constant. It has no constant. You will see in later on the difference. But here you should understand that this singular solution is not a this particular solution. Particular solution we get from the general solution when we replace the constants by some values, which values are defined from the problem itself. But here it is a solution. This is some sort of solution which also satisfies the given differential equation but involving no constant, and this type of solution is not obtained from the general solution of the differential. Every differential equation has a general solution, but this is not obtainable from this is some other solution. There are so many solutions of the problem. This is also one of the solutions of the problem, but this solution will not contain the arbitrarily constants. It is known as singular solution. Okay, let me have some applications so that you will come to know what is the solution of the differential equation. Let us have application show that y is equal to 3 cos x plus 4 sin x. is the solution of differential equation d2y dx square plus y 0. First I will check is this the solution of this, then I will explain which type of solution it is. It involves constants, but constants are not now arbitrarily. Arbitrarily constants are replaced. Arbitrarily constants are replaced. 3, 4, these are the constants, but these are replaced. Once they are replaced, they become particular. Otherwise, this differential equation is of second order. It is of second order differential equation. In its solution, it should have two arbitrarily constant general solutions, C1 and C2. But we are testing here that this is also the solution. But here it does not involve general constants C1 and C2. It involves particular constants, fixed constants 3 and 4. So we say that this solution is a particular. Let us first see, is this a solution or not? Let us check. Solution. This is your first differential equation. I have y is equal to 3 cos x plus 4 sin x. I have to check, is this the solution of this differential equation? What is the solution? It is a relation between x and y. It is a relation between, we said in the definition, this relation and derivative obtained from this should satisfy the given differential equation. It should satisfy. Let us see, is it satisfy? Differentiate this. Differentiate with respect to x. It is dy by dx is minus 3 sin x, derivative of cos is minus sin, plus 4 cos x. Then I need d2y. What is d2y by dx square? It is minus 3 cos x minus 4 sin x. This is third. This is value of y. This is derivative we needed. Using second and third in first. What is d2y by dx square? It is minus 3 cos x minus 4 sin x. What is y? It is 3 cos x plus 4 sin x is equal to 0. This is 0 is equal to 0. Yes, this is the solution. Yes, y is equal to 3 cos x plus 4 sin x is solution of first equation. And which type of solution it is now? This solution is a particular solution. This solution is particular solution because it does not involve general constants, it involves fixed constants. The solution is particular. It is an observation of this solution. Is a particular solution because the constants are fixed, they are replaced. Well, let me take some more example. Verify if y is equal to c by x plus d is the solution of given differential equation d2y dx square plus 2 by x dy by dx is equal to 0. Whether this is the solution of the differential equation, it is dy by dx, d2 by 2 by x plus dy by dx equal to 0. Let us verify it. Is this a solution? Y is equal to c by x plus d. This is your given solution, this is the given differential equation. Let us take the solution. We require here d2y by dx square and we require dy by dx. We will use them here. We will check if that does it satisfy or not. You see, from first, what is dy by dx here? When you differentiate this, c is constant, d is constant. What is the derivative of 1 by x with respect to x? Minus 1 by x square. So it is minus c by x square. Derivative of this plus 0. So it is dy by dx is minus c x raised to power minus 2. Third, differentiate again. It is d2y by dx square. This is plus 2c x raised to power what? Minus 3. So your d2y by dx square is 2c by x cube. This is equation number 4. Now use this third and fourth in second, given differential equation I mean, using second and third in third and fourth. This is fourth. Third and fourth in second equation. Let us use it in second equation. Let us see what it gives. You have d2y by dx square value, it is this. It is 2c by x cube, then plus 2 by x. What is dy by dx? It is minus c x raised to power minus 2 is equal to 0. This gives you 2c by x cube. This is again minus 2c by x cube is equal to 0. It is 0 is equal to 0. Yes. Y is equal to c by x plus d is solution of second equation. It is a solution of second equation. Now which type of solution it is? You don't have here arbitrarily values of c1 and c2. You have the general value. Here constant c and d are involved. General constant. So it is solution is general. Solution is general or complete integral solution. It is complete integral solution as it involves two what? Arbitrarily constants, that is c and d. It involves two arbitrarily constant c and d. Okay. This is about solution, how we find out the solution of the differential equation. Now we are coming closer to this. We shall first deal with the solution of solutions of differential equations. In fact, ordinary differential equations we are dealing with solutions of differential equations of first order and first degree. First order and first degree. It is the part of your syllabus. Everywhere when we take the concepts of differential equations, first we define these things. What is the differential equation? What we mean by the solution of a differential equation? What are the types of the the solutions? Then we find in first stage how we solve the differential equations of first order and first degree. It is in everywhere. Even in 12th class students, they too have this concept, variable separable method. There they do it. so it will also help them if they watch this video. Okay, solution of differential equation of first order and first degree. I will write what we mean by this. A differential equation of the form, a differential equation of the form dy by dx is equal to some function of xy, f of xy. It involves dy by dx. Highest order is 1, highest degree is also 1. Differential equation of the form, or you may have this form, or sometimes you write m dx plus n dy is equal to c or 0, where m and n, capital M and capital N, are some functions of x and y. They are functions of x and y. This we can write the differential equation of first order and first degree either of this form, or it is m dx plus n dy. You will come across in future m dx plus n dy form. So I wrote here it is also this first order and first degree differential equation. We can say in this way also. Now we have the methods of solution for these differential equations. What is the methods of solution? Let us discuss methods of solution. We are now presently dealing with differential equations of first order and first degree. First order and first degree, we will discuss for them methods of solution. Methods of solution. For what this is methods of solution? Methods of solution for differential equation of first order and first degree. I will write here, I will mention here, in general, there is no fixed or general method for solving ordinary differential equations of first order and first degree. No general method, no fixed method, but how we proceed. But there are differential equations of first order and first degree which are of standard form, standard type. There are first order, some take the standard type exact, some take the form dy by dx plus py is equal to q. It is a standard, this differential equation, linear differential equation. It is a standard, we say it is a standard type. Some are differential equations of first order and first degree where we can separate the variables. It is also some standard type. So, but some of the first order and first degree differential equations are of standard or of certain standard, certain standard type. They take, some of them take what? Standard types, certain standard types for which we have the solutions available. Therefore, when you solve a differential equation of first order and first degree, it is very necessary I have mentioned here, there is no fixed method for solving this differential equation of first order and first degree, but some of them, what they do, they take the turn of standard type, some standard type, when they have some certain standard type for which we have the solutions available. Now we will discuss those standard types. Number one standard types will be, it will be now method of solution for differential equations of first order and first degree. First will be variable or separable. Some first order differential equations are such that where we can separate all the functions of x with dx, functions of y with dy, and we can solve them. It is first method. Then next you have the homogeneous, the first order and first differential equation which can be put in the homogeneous form. We have to discuss with you homogeneous. Then some of them are the LD, linear differential equations. We call them linear differential equations, dy by dx plus py is equal to q. Then next we have the Bernoulli's differential equation of first order, Bernoulli's. Then we have the exact differential equations, reducible to exact differential equations, so on. This is something we have to now do for this solution of differential equations of first order and first degree. With this I conclude here. I will go to now next lecture we will meet, inshallah. Next lecture, there we will have this solutions, how we solve the differential equations. I will give you the variable separable method, then some problems on that, then homogeneous problems on that, and we will go now solution of the differential equation. Thank you very much. I hope you are following my lecture, you are doing best at your places, you are revising the things and taking extra care of this COVID pandemic second wave. Thank you very much, students.